Hi all, welcome to the first module in the Performance and Security unit. We're going to talk about authentication with HTTP, and this will take us into interesting discussions about how the HTTP protocol works. We're talking about usernames, passwords, and the concept of session tokens and cookies. We'll also be looking at how usernames and passwords are stored in the database and why they're stored in a particular way. So far over the last few units, we've understood the basics of how a web app works. We've understood what the client-server architecture looks like and what the different constraints are. We've also built a basic web app and we understand what the front-end code and the back-end code looks like. And we've also explored the database in a fair amount of depth. HTTP is what is called a stateless protocol. What this means is that one HTTP request that is made by the browser actually has nothing to do with another HTTP request. From the server's point of view, when the server gets an HTTP request, both of those requests are completely independent. We have seen this even in the code that we wrote. In the Node.js code that we were writing, we were handling each request independently. Nowhere in the request were we factoring in the fact that we knew that when somebody has made request 1, we also know if that person is making request 2. Whenever a request is made, the browser opens up an HTTP connection. It sends a URL, the headers, and the request body. The server then responds with an HTTP response. That means it contains a status code, it contains some response headers, and it contains a response body. And then the browser closes the HTTP connection. So this is one request response cycle. If this is how HTTP works, then how does login work? For example, if I go to Gmail and I log in, and then I make an API request to fetch my email data, how does that login process work? What if I just directly make the API request to fetch the emails? Or what if I directly go to my inbox page? How does Google know, or how does the Gmail server know that I'm trying to make a request to the inbox page and I'm not logged in, so I should be redirected to the login page? And then once I'm logged in, how does the Gmail server know that this is user Tanmay Gopal who is requesting his email data? How is that link maintained? So just to explain this problem to you more clearly, on the left we have a browser. The browser first goes to the login page and makes a login request. Let's say he's logging in with the username user90. This is user90 who's trying to log in. So the user90 sends a username and a password to the Gmail server. The Gmail server checks with the database to see if the username and password are accurate. And if the password matches for the username, the Gmail server returns a successful login response. Then the browser sends a fetch email request. But how does the Gmail know whose emails to respond with? How does the Gmail server know whether this is the same person who made the request for logging in successfully, right? How is that link maintained? So the only way to solve this problem is that the server should send a special string, unguessable or a random string preferably, and we can call this a session token. So the server has to send a session token, and for all subsequent requests that the web app makes, it should use this session token. So let's try to see what this flow looks like. Once the login is done and Gmail verifies that the login credentials are correct, Gmail does not just reply saying that the login is successful. The Gmail also sends a secret token, and this can be like a 128-bit or a 256-bit string which is sent back to the browser. The next request, for example, the request that is made to fetch the inbox page or to fetch the emails via an API, this request contains this token. And when this token is sent to Gmail, Gmail has stored this token already in its database. So Gmail says that the token has come and this token belongs to the user 90. And because this token belongs to the user 90, Gmail server can now respond with user 90's emails, right? So this solves the problem of carrying forward information from one request response into another. And it also solves the problem of authentication for Gmail to understand who is making API requests, right? So a session ID or a session token is generated by a server and it needs to be sent along with every request by the client, which in our case is the browser. It's important to understand that if the session ID is lost or compromised and a hacker gets access to our session ID, then the hacker can make requests using that session ID, which will allow the hacker to fetch the data that belongs to the user. Another important property of the session ID or the session token is that the client-side JavaScript must use this session token every time it makes an AJAX or an API request, and also when the browser requests access to a privileged page, for example the /emails page or the /inbox page, then the token should also be sent along for those page requests. So how do we send this secret token to the server? For example, if we are the developers who are writing the front end or the HTML and the JavaScript of a particular application, how will we send this secret token to the server when we are making requests? We have many options, and in fact we can do whatever is convenient to us. So if we are in control of both the front end code and the back end code, meaning the client side code and the server side code, then we can agree on any particular contract to send our secret token. For example, we can send it as a get parameter, we can send the token as a part of the request body. The standard way to do it is to send it as a HTTP header, what is called an authorization header. So let's see what this looks like. When the browser is now making a request to the Gmail server, it's making an authorized request. It might be making an API request, or it might be making a request for a page. So there are many different ways that the token can be sent. For example, in a get request, you can say token equal to. So that means that this parameter is sent, and what the Gmail server will be doing is it will extract the value of this token and check if you have access to this emails page. Another way to do it is to make a get or a post request, but send what is called an HTTP header that contains authorization and the token. So this is called an authorization header. In fact, you can create your own HTTP header. You can call it my secret token, and that can be the name of your HTTP header, and you can send the token as a value in that. You can also make a post request to an endpoint, and this would typically be an API. In this case, we can send the token even as a request body. However, the standard way to do it is to use an HTTP header. If you think about it, this is actually a little inconvenient. Every single API request that we make, we would have to remember to attach the token when we make that request. And this entire system breaks down if you want to have access to special pages. For example, suppose we have a page called server.com/emails, and this is actually a web page, right? We want to have an endpoint that looks nice. For example, we want to say server.com/emails. I don't want my endpoint to be server.com/emails token equal. A real example for this is your Facebook profile page. When you go to your Facebook profile page, you go to facebook.com/username, right? So in my case, it would be say facebook.com/tanmay. So if you try to go to this page, how can we send along our token so that Facebook knows that we actually have access to this page, right? Because there is no way for us to send an extra parameter as a part of the URL, because we want our URLs to look good, or we want to be able to save these URLs. So to solve this kind of a problem, something called cookies exist. Cookies are just like HTTP headers, but they're special HTTP headers. These HTTP headers are automatically managed by the browser. If a cookie has been set for a particular domain, the browser takes on the responsibility of making sure that that HTTP header is always sent to the server. So a cookie is just another HTTP header, but it's a special HTTP header in the sense that the browser always attaches that HTTP header whenever it makes a request. This request can be a get request. For example, it can be the link to a web page, or this request can be a post request, which is an API request, but the browser will take the responsibility of sending this HTTP header. Cookies are tied to a specific domain, so that means that you can send a cookie only to a specific domain. Cookies that are created by the Gmail server will not be attached by the browser for the Facebook server. Cookies can have an expiry time, so the browser will automatically take care of deleting that cookie and not send that as an HTTP header after the expiry time is crossed. The server can request the client to set a cookie, so cookies can be set by the server. Of course, the client may or may not decide to set the cookie. For example, if I'm making a request from the terminal, where if I make a curl request, or I use a command called curl, or I use a command called wget to make a request, then cookies are not managed by these commands. But when the client is a browser, the browser understands the cookie header and actually sets the cookie. So to see cookies that are being used on whatever site that you are on, go to a web page, right click, open up inspect element, head to the network tab, click on a particular request, and then click on the cookies tab that you will see. When you click on the cookies tab, you will see all the different cookies that are being sent to the Gmail server whenever a request is being made. In Gmail's case, they are using a lot of different cookies for different purposes, but the cookies that are of importance to us are probably the SID and the SSID cookie, which contain our identity. If you head to the IMAD console, you will see that a particular cookie is being used to identify who you are as a user to actually handle the login. So for example, in this case, you see this cookie, and this cookie has a particular value. So using this value, the server knows that when you go to cloud.imad.io, it loads up the page that is relevant to you. This is how the IMAD console works. For example, if I log in, I will see my homepage with my database credentials, my SSH credentials, and when I click on code console, it will load up my GitHub page, right? Similarly, if you are logged in and you go to cloud.imad.io, it will load your credentials, right? And the way this is done is because it has access to this cookie, and the server uses this cookie to figure out your identity. So cookies are basically pieces of data that are automatically attached to a request made to the same domain. This makes cookies useful for all kinds of different things, not just using them as mechanisms to exchange session information or exchange authentication token. Cookies are used, most commonly cookies are used for tracking. This is why you might have heard that cookies are dangerous or cookies are used for tracking. And this is in fact how Google Analytics or how most tracking services work. They have a particular cookie that they set, and then whenever you visit a page, the Google Analytics script makes a request to the Google Analytics server using that cookie, and that is how Google Analytics knows what are the different pages that are being visited by the same particular user. As I mentioned earlier, cookies can be set by the server, but a cookie can also be set by the client-side JavaScript. So for example, we can use cookies for creating shopping cart experiences. Let's say, for example, you're on an e-commerce site, and many e-commerce sites allow you to add items to a cart without actually logging in. So this means that whenever you add an item to a cart, the entire cart data is actually stored on a cookie, which means if you shut your browser page and your e-commerce site again on the same browser, the browser will show you your cart that contains all the old cart items because the cookie is still there, right? So we can use a cookie for storing client-side information as well. Very, very important to understand that cookies are completely under the control of a browser. So if the browser is a malicious browser or the browser has a bug, then the browser might send incorrect cookies, but the browser might not send cookies at all. It is simply a convention that the browser follows in which it decides to send cookies to the server again. Now that we've understood how session tokens work and how we can exchange session tokens with the servers, let's come back to the idea of a username and a password. When we log in, we send the username and a password to our server. Our server compares the username and password by values that it already has. Typically, the value is stored in a database. So for example, we might have a database table that contains two columns, username and password. And let's say user 1 has a password called my password and user 2 has a password called my new pass. When we try to log in, our web app will fetch the login credentials for the same username that has been given in the login and match the password values. If the password values are the same, then the server will respond to a successful login. However, this is actually a little dangerous. And the reason why this is dangerous is because anybody who can get access to this table's data, which is unfortunately a fairly common attack where hackers are able to get access to the database, in that case, hackers now have access to the raw password that is stored by every user. So that means the hacker can now log in, can pretend to be user 1. The hacker can also start doing actions that are controlled by the password. For example, changing your password, or for example, authorizing a transaction. On many e-commerce sites or on many banking sites, you will be asked to enter your password or your PIN number again. So not only does the hacker have access to your data, but the hacker can also start making privileged transactions because the password is available raw. It might seem like there is no alternative and this is the only way to solve the problem and the only thing that we can do is secure access to a database, but there is actually a very interesting way to try to solve this problem. We can store passwords and we can store password-like objects quite securely in a database. There is a function called a hash function, and a hash function is a rather amazing mathematical function that converts any string into a fixed length randomized string. And the amazing thing about the hash function is that you can go from one direction to the other. So you can hash the value of my password and convert this into a random string, but you can't go back. That means that even if you know what the hash function is and you know the algorithm of the function that is being used and you have this random string, it is almost impossible for you to recover the original string that this hash value came from. And this is one of the most amazing mathematical inventions that has made modern username and password functionality possible. So now the way the servers work is that whenever a login credential comes with say user 1 and my password, the web app fetches the data from the database, it fetches the data belonging to user 1, it fetches this password hash. The web app takes the password that has been given in the login credential, which is my password, applies the hash algorithm on it and compares that to the password hash that it had in the database. If those two hashes match, then the passwords are the same. And if the hashes don't match, then the passwords are not the same. This allows us to compare passwords without knowing what the password really is. So in this module, we understood how HTTP is a stateless protocol and how that means that as developers, we have to send extra data that can help us tie multiple HTTP requests to the same context. We understood that we can use the concept of a session token to maintain a login session. We also know that the session token can be exchanged with the server in whatever format that we choose. We looked at two popular conventions for sending this session token. One is sending it as a HTTP header, as an authorization header. There is another popular convention of cookies which are used to exchange this information. We also understood that cookies are actually more useful than just sending session tokens, and they can be used for doing several things like tracking or storing client-side information. We also looked at the concept of hashing and how passwords are securely stored in a database.